So, I was cleaning up my room this weekend and I found a crystal tree kit. So, I figured I would do the making of and science behind crystal trees. So, what do you need to make a crystal tree? First, you need salt, water, and some cardboard tree cutouts. That's about it. You can add a bunch of extras. You can add ammonia, which helps the water evaporate faster and the crystals form quicker. You can add a colloid solution, like liquid bluing. This acts as a seed crystal and makes the crystals grow bigger. Or you can add a food colouring as well, making them turn pretty colours. All of these are optionals, but you can play around as you wish. Now, I'd like everyone to appreciate the fact that I gave my phone up for 22 hours to film this time-lapse footage. As you can see, making a crystal tree isn't something that happens quickly. You can set it up one afternoon and come back in the morning and see what happens. Now, as you can see, it's formed these beautiful pink blossoms. Well, I'll call them blossoms. Beautiful pink crystals all over the tree. So, how do crystal trees work? There's three main reasons. They work through capillary action, evaporation, and crystallization. Now, start with capillary action. What's capillary action? Well, capillary action is actually how trees get water. It's where liquids move up a thin tube against the force of gravity. Cardboard is porous, so the bubbles of air in it form a network of small spaces that encourage capillary action to occur. But how? Well, it's a mixture of surface tension and adhesive forces. So the surface tension of the water interacting with the adhesive forces between the water and the cardboard act together to push the water up to where there isn't any. Imagine dipping the corner of a paper towel into a glass of water. The water spreads upwards through the towel, even to the parts that haven't been dunked. That's capillary action. So, now that we know how it works, what is the point of it in crystal trees? Well, it pulls the solution up the tree into all the branches. Now, the solution carries the seeds of the crystal, so it pulls it up into the branches and ensures that the crystals will form everywhere. It also means that unlike doing something like dunking the tree in the solution, the tree doesn't become too soggy to collapse in and of itself, which would be a risk. The other risk with dunking is that the solution doesn't permeate through the tree, so the crystals that form are uneven or blotchy. Either way, capillary action is definitely the best choice. Now we're on to evaporation. Well, evaporation, most people will probably know, but I'll cover it anyway. It is when liquids turn into gas. So everything's made of molecules or elements or atoms, essentially. When they're close together, they form solid. When they get a little further apart, they become a liquid. And when they become really far apart, they're a gas. So evaporation is when a liquid gains enough energy, normally through heat, and becomes a gas. So when the molecules become hotter or gain more energy, they shake. And as they shake, they put more space between them, turning them from a solid to a liquid to a gas. When they're a gas, they're moving very quickly. In fact, they're going nowhere near each other because they're taking up so much more space. So in crystal trees, the liquid evaporates and leaving behind the salt particles. The particles then form the crystal lattices and the tree blooms. So the liquid's mainly the delivery system. Evaporation removes it, which allows the crystals to grow. Now, the only reason you'd add ammonia in it is because it makes evaporation occur quicker, which means that the trees bloom faster. In winter, that can be pretty important. In summer, so long as it's in a hot place, not so much. The heat will remove the liquid and allow the salt to crystallise quickly. Now, we're on to the amazing crystallization. Now, I've got to admit, this is my favourite bit. I love crystals, and I've done a lot of study on crystals and science. So what it is the atoms form rigid structures called a crystal lattice around the central point of the nucleus. So some atoms have very specific interactions with each other. They form bonds between each other in particular ways. The most common and most simple is salt. The chloride and the sodium form strict bonds between themselves, forming a square lattice. Now, when a solution of some type of molecules is crystallised, the liquids remove slowly. The solute precipitates or condenses at the bottom. First, nucleation occurs, so there's a particle around which other particles begin to condense. Then crystal growth occurs, and the crystal structure forms and expands. That's the blooming. So it's where the magic happens. The salt normally begins to crystallize around the tiny colloid particles. If you don't have the colloid particles to act as a nucleus, then, well, it'll still crystallize, but the crystals will be smaller and possibly more fragile. So that is the science behind crystal trees.